We've seen that Python acts in a pretty radical way when an exception occurs. By default, Python simply interrupts your program, prints a message, and exits. But in some cases, and in fact, in most cases, we'll want to handle these exceptions in a more graceful manner and give ourselves the chance to correct course. For example, we may want to execute an alternative set of statements if an error occurs, and resume the normal execution of the program thereafter. Python allows you to handle exceptions through a try-except block with the syntax shown here. This block starts with a try keyword and a colon character, followed by a set of indented statements. Next, we use the except keyword, followed by an optional exception type, a colon character, and another set of indented statements. This is the way it works. Python starts executing statements in the try block. If any of these statements causes an exception, the try block is immediately interrupted, and control is transferred to the except block. If, on the contrary, running the statements in the try block causes no exception, the except block is skipped altogether, and the execution continues after the next non-indented statement. If the except keyword does not include any specific exception type, the behavior I just described applies to any type of exception. On the contrary, if a specific exception type is given, only exceptions of that type are captured by the except block, and any other exception will be handled with a standard method of terminating your program. Also, notice that you may add as many additional except blocks as you'd like to handle different exceptions in different ways according to their type. I'll show you two examples on how to use a try-except block with and without specific exception types. Let's start with a case in which no specific exception type is given. The following program reads two input operands from the user, converts them into integers, and saves them in variables op1 and op2. The program then calculates the division of these numbers and prints the result. All this occurs within the try section of a try-except block, where the except section will capture exceptions of any type. If an exception occurs, the try block is interrupted and control is immediately transferred to the except block, where the program prints a string reading "something went wrong." Now, what is it that could go wrong in the try block? There are two different types of exceptions that could occur here. First, we could get an exception of type value error if any of the string to integer conversions fail due to the user entering an invalid numeric value. Second, we could get an exception of type zero division error if the second operand entered by the user is 0. Both types of errors are handled homogeneously by the single except block present in this code. Let's try executing this program. First, let's enter two valid input operands set to 10 and 2. In this case, the operation succeeds, and the result of the division is printed. Let's now run it again, but this time we'll enter an invalid first input operand, for example, string A. The string to integer conversion fails, and the except block prints our custom error message, "Something went wrong." Let's run the program one last time. This time we'll enter two input numbers set to 5 and 0. In this case, the division fails, and the except block once again prints our custom error message, "Something went wrong." If you enjoyed this content, you may watch the rest of this lesson at computersciencecamp.com, linked in the description below. You'll be able to follow along with coding samples and problems in our embedded code editor. Drop your questions in the comment section below, and don't forget to like and subscribe to help support the channel. Thank you, and happy coding!